Hello, welcome to A Plus Tutoring, and we will be dealing with algebra solving for x. Okay, so we have a question that says x cubed is equal to 9x, right? So we are not going to divide by x because it can happen that your first instinct says divide both sides by x. I mean, there's x this side, there's x that side, divide by x. No, when you're solving for x, you're gonna transpose and leave it as a 0. So we now have x cubed minus 9x is equal to 0. Why did I do this? Is because if you are to divide by x, right, you've eliminated your other x value. So this actually tells you that you have 3x values, but if you divide by x, you now have only 2x values. So you have eliminated your other answer. So when you now do this, you can now factor out that x and say you have x squared minus 9 is equal to 0. Now, when you look at x squared minus 9, this is difference of perfect squares. Remember, difference of perfect squares is like x squared minus b squared. So this only works when it's a minus. When it's a plus, it doesn't work. When it's a minus, that's when it works. So it's difference of perfect squares. So when it's now like this, we have open two brackets where we have x, b, and then one is negative, one is positive, right? So we're going to change 9 to be something squared, right? Meaning find the square root of 9. What is it? It's 3, right? So we now have x squared minus 3 squared, which now will now be our two brackets, right? We have x 3, one is plus, one is minus, and everything is equal to 0. Meaning now we have three options. We now have x is equal to 0. We have x plus 3 is equal to 0. We now also have x minus 3 is equal to 0. So we now have x is equal to 0 as an answer. X plus 3 is equal to 0, which will give us x is equal to minus 3. And then x minus 3 is equal to 0, which will give us x is equal to 3. Okay. Now, p is equal to 3 over 2x, open bracket, p q squared minus pq squared, right? We want to solve for x, meaning we want to leave x alone. So the first thing we're going to do is divide both sides by the pq squared minus pq squared, right? So we now have p over your pq squared minus pq squared is equal to 3 over 2x, right? And then do you see that p is common in the denominator? So when we now take it out, we now have, let me just try to use a different color. We now have p over p into q squared minus q squared is equal to 3 over 2x, right? This will cancel with that, so we remain with 1 over q squared minus q squared is equal to 3 over 2x. But we want x, so we have to times by 2 over 3. We have to times by 2 over 3 on both sides, meaning even this side you times by 2 over 3. So our answer is now 2 over 3 q squared minus q squared is equal to x. Okay. Now we have 3 x to the power of 3 over 4 is equal to 81. The first thing we're going to do is divide by 3, because we only want to remain with the x and its power, right? We divide both sides by 3. Now, we now have x, 3 over 4. What is 81 divided by 3? That should be 27, if I'm not mistaken. Let me just verify. I forgot that I need a calculator for this. 81 divided by 3 is 27. Okay, so we now have 27. Okay, so we can change 27 to be an exponent, right? Which you put in your calculator, just say 27 is equal to, and then shift fact, which you get 3 to the power of 3, right? So we now have x is equal to that x to the power that is 3 to the power of 3. Now we want to get rid of this 3 over 4. That means that we're now going to put it to the power of 4 over 3. Why? Because if you have an exponent, right, and then you power it to something, the exponents are going to multiply, meaning we end up with a to the power of 2x, right? So for those ones, since we have a 3 over 4, if I multiply it by its reciprocal, they're gonna cancel and I end up with 1. So I'll just now end up with x is equal to, this side I also to the power of 4 over 3, meaning that it's now 3 times 4 over 3, which this and this cancels and I end up with 4. So I now have 3 to the power of 4. And then x is now equal to 81. Okay, so then will now be your final answer. Now they want us to solve for x in an inequality. So an inequality, you're still solving it the same way you solve as if you have an equal sign, right? You solve it the same way you solve it as if you have an equal sign, meaning that you're dividing both sides by 3. So we have 2 minus 3x is greater or equal to 15. First thing is we're going to divide both sides by 3. So that we now remain by 2 minus 3x is greater or equal to 5. Alright. And then what do? We now transpose this 2 to that side. We now have minus 3x. It's greater or equal to 5 minus 2 because it was positive, right? Which will now give us 3. Now, we now just want to remain with the x here. So we're going to have to divide by minus 3. But when you divide by a minus number, now when it comes to inequalities, when you divide by a minus number, your sign changes direction. So it was facing that way, right? Meaning it's now going to face this way. So it will now look like that. And then the x and then minus 1. So this will now be your final answer for 2.2.1. Now they say hence represent your answer on a number line. Now what does this mean? This means that x is what? Less or equal to minus 1, right? So on our number line, we have your 0, your minus 1, right? It said it's less or equal to minus 1. Now, since it's equal, we shade our dot. If it was just less, if they just said x is less than minus 1, right, would have an open one. But because it's less or equal, that's why we have a shaded one. Now, they say it is, because it's the one eating the minus 1, right, it's less, meaning we're going in that direction. And that will be your number line. Now, solve simultaneously x and y. So we have two equations. This is our equation 1 and we have our equation 2. Okay, so from these two equations, you can make what? An equation 3. What is an equation 3? An equation 3 is whereby you look at which one from 1 and 2. Which one is easy for me to say, to change it to be something like x is equal to, right? Or y is equal to, right? And when we look at equation 2, it's easy for me to transpose everything and remain with y, right? And have y is equal to. So now I'm going to transpose my y to that side because it was negative. I want it to be positive. It now comes that side. But now that means that my 3x now goes that side. It was positive this side, so it becomes negative when it goes there. So I now have y is equal to 2 minus 3x. Right? This is now my equation 3. Now I'm going to take my equation 3 and substitute it in equation 1. You don't substitute it in the equation that you derived it from. So I made equation 3 from equation 2, right? Meaning I'm not going to take equation 3 and put it in equation 2. I'm going to take equation 3 and put it in equation 1. So now in place of y, I'm now going to put 2 minus 3x. So where there is y, I now put 2 minus 3x. So I have 3x plus 2y, right? In place of y, I now put 2 minus 3x is equal to 13. Now let me open my bracket. I now have 2 times 2, that is 4. 2 times minus 3, that is now minus 6x, is equal to 13. I now transpose the 4 to that side and then combine the x's, right? Because they are what? Like terms. So now it's now 3 minus 6x, that's minus 3x. And then it's now 13 minus 4, which is 9, right? Now I want to get rid of minus 3, so I divide minus 3 both sides, and my x is minus 3. So now I have the answer for x. Now what do? I now take this x and go put it in equation 3, because already equation 3 says y is equal to, and I want y, right? So I now just go put it in there and say y is equal to minus 3 in place of x. I now put what I got as my answer, and I now have 2 plus 9, which will be 11. So now I have x is equal to minus 3 and y equals to 11. And those will be your answers for your simultaneous equations. Okay, thank you for staying with me, and please like, subscribe, comment, and I'll see you guys in the next video.